modern astronomy was built by women, history almost erased. The men upstairs became immortal. The women downstairs mapped the universe for 25 cents an hour. They classified hundreds of thousands of stars by hand. They discovered how far the cosmos extends. Most people have never heard their names. Harvard Observatory, in the late 19th century, was the most prestigious astronomical institution in the world. It was also running what amounts to one of the most sophisticated intellectual labor operations in scientific history. One, built deliberately on the calculation that women's minds could be purchased for a fraction of what men's commanded, and that the knowledge produced by those minds could be attributed upward to the institution, rather than outward to the individuals who generated it. The story of what happened inside those rooms is one that modern astronomy has not fully reckoned with. The debt is older than anyone now living, and it has never been properly paid. Welcome back to Medusa Awakened, where we unearth the voices they tried to bury. In 1881, Edward Charles Pickering, the director of Harvard College Observatory, made a decision that would reshape astronomy, while appearing to be a purely administrative act of cost management. He was frustrated with his male assistant's inability to perform calculations with the accuracy and consistency the work required. So he fired him. And he replaced him with his Scottish housekeeper, Williamina Fleming. The logic was transparent and brutal. Women could be paid a fraction of what men earned, and the work Pickering needed done required meticulous attention to detail, rather than the kind of theoretical prominence that male astronomers expected to be financially recognized for. The operation expanded. He hired more women. They sat at long tables in a room adjacent to the telescope facilities, analyzing glass photographic plates, measuring the spectra of stars, performing the calculations that translated raw astronomical data into scientific knowledge. They were called the Harvard computers. The word was not metaphorical. They were human calculating machines, employed specifically because their labor was cheaper than men's, and considered by the institution to be categorically different from the scientific thinking that male astronomers performed. The men observed. The women computed. The men theorized. The women verified. The men published. The women were sometimes mentioned in footnotes, occasionally acknowledged in prefaces, and more often credited only as a collective. A nameless team of institutional support, rather than as individual scientific minds doing individual scientific work of individual scientific significance. The knowledge flowed upward to the men with public names. The credit did not flow back down to the women with glass plates. It never does. That is not an accident. That is architecture. Williamina Fleming had no formal scientific training when Pickering brought her in from domestic service. What she had was a precision of mind that the observatory could not afford to ignore once it became visible. She developed a system for classifying stellar spectra, organizing stars into categories based on the absorption lines in their light. A classification that would become the foundation for understanding what stars are chemically composed of. She personally classified over 10,000 stars across her career. She discovered the Horsehead Nebula, one of the most visually iconic structures in the known universe. She became curator of astronomical photographs, a title that sounds administrative, but was in fact a recognition that her scientific contribution could no longer be contained within the category of clerical labor, even by an institution deeply motivated to keep it there. Annie Jump Cannon arrived at Harvard in 1896 with a passion for stellar physics that the institution was glad to exploit and reluctant to fully reward. What she built was a reclassification of stars so elegant and so comprehensive that it is still in use today. The OBAFGKM sequence, the ordering of stars by temperature and spectral characteristics that every astronomy student still memorizes, is Cannon's system. Every astronomer alive learned it from her without knowing her name. She classified around 350,000 stars over the course of her career, doing so at a rate of approximately 3 per minute using nothing but a magnifying glass and a trained eye. Her classification framework is not a historical artifact of early astronomy. It is the active operating language through which astronomers understand the life cycle of stars today. She was not made a permanent staff member with a proper title for decades. When the appointment finally came, it arrived long after the work that had warranted it was already embedded in the infrastructure of the discipline. Henrietta Swan Leavitt may have made the single most consequential observational discovery in the history of astronomy relative to the institutional recognition she received for it. She worked at the observatory initially as an unpaid volunteer, before being hired as a paid computer at 30 cents an hour. She was assigned to study Cepheid variable stars, stars whose brightness pulses in rhythmic cycles. Inside those cycles, she found something that no one had anticipated. She discovered that the period of a variable star's pulsation is directly and mathematically related to its intrinsic luminosity. The longer this cycle, the brighter the star. The implications were immediate and enormous. If you could measure how long a Cepheid took to pulse, you could calculate its actual brightness. And if you knew its actual brightness and could observe how dim it appeared from Earth, you could calculate the distance between you and the star with a precision that had previously been impossible. Leavitt had handed astronomy the first reliable ruler for measuring cosmic distances. Edwin Hubble used her method to demonstrate that the Andromeda Galaxy lies far outside the Milky Way, proving that our galaxy is one among many and that the universe is vastly larger than anyone had believed. Hubble became famous. Leavitt was nominated for the Nobel Prize in 1924. The committee wrote to notify her. Pickering had to inform them that she had died of cancer 3 years earlier. The Nobel is not awarded posthumously. The work that measured the scale of the universe had already passed out of institutional memory before the institution remembered to honor it. Cecilia Payne arrived at Harvard in 1923, having completed her studies at Cambridge, England, where she could not receive a degree because Cambridge did not award degrees to women. Her doctoral thesis, submitted at Harvard, is now regarded by many historians of science as the most important astronomical dissertation ever written. She determined that stars are overwhelmingly composed of hydrogen and helium, directly contradicting the prevailing assumption that they were made of heavier metals similar to those that compose the Earth. This was not an incremental refinement. It was a complete restructuring of the foundational picture of what the universe is made of. The establishment's response was to tell her she was wrong. Henry Norris Russell, one of the most prominent astronomers of the era, persuaded her to include a statement in her thesis, indicating that the apparent abundance of hydrogen was almost certainly not real. He was wrong. She was right. He later arrived at the same conclusion through his own analysis, and received recognition for the finding. She eventually received the acknowledgement that the discovery had been hers, but that acknowledgement arrived quietly in subsequent papers. Years after the finding had already entered the literature under other names. She was not appointed full professor at Harvard until 1956, making her the first woman to hold that rank in the Faculty of Arts and Sciences. The appointment came more than 3 decades after the work that had merited it. The institution she had helped make great took 30 years to admit it. If you believe history was engineered to immortalize powerful men while burying the women who built modern science in silence, subscribe to Medusa Awakened. Let us uncover what history tried to erase. The institutions that employed these women understood, even if they did not articulate it, that what the computers were doing was not merely computation. The work required scientific judgment. It required the ability to identify anomalies in data, to recognize patterns that had not been described before, to make classification decisions that would shape how the entire field understood its material. Pickering published papers based on the work of his computers. The papers carried his name. The individual contributions of the women who had generated the knowledge inside those papers were visible in the internal records of the observatory, in logbooks and correspondence and private journals, but not in the literature that determined scientific reputation and professional standing. The names that traveled through journals, into textbooks, onto the committees that awarded prizes, were male names. The knowledge those names were built on frequently originated with women whose contribution was institutionally categorized as support rather than science. This categorization was not accidental, it was structural. It was the mechanism through which scientific institutions of that era managed the contradiction between needing women's intellectual labor and refusing women's full intellectual standing. You could employ a woman to perform the analysis. You could not acknowledge that the analysis was science. Because if you did, you would have to admit who the scientists were, and that admission would have cost them everything they had arranged the system to protect. The period luminosity relationship that Leavitt discovered is still the foundational method for measuring distances to galaxies. Canon's stellar classification is still the framework astronomers use to describe and categorize stars. The catalogs Fleming compiled are still referenced in astronomical literature. The work of the Harvard computers is not stored history. It is operational science. It is inside the instruments that explore the edges of the observable universe. It is inside the calculations that map the cosmic microwave background radiation. It is inside every measurement that depends on knowing how far away something is or what type of star produced its light. The institutions kept the glory. The women kept the science. The Harvard computers mapped the distances between galaxies before anyone understood that galaxies were distinct from our own. They decoded the chemical composition of the stars at a time when that composition was entirely unknown. They built the classification systems that modern astrophysics still uses as its primary operating language. The institutions called them computers. The universe called them discoverers. The moment their findings entered the data, they calculated the distance to the edge of the known universe from a room where they were paid less than a factory worker. History forgot their names. The universe did not, and the stars they cataloged have not moved. They were called computers. They were scientists. The universe still runs on their calculations. The stars they named, remember who named them.